Hey everyone, welcome back. I'm trying a new format today with the whiteboard. I hope it's more interactive and better for you guys to understand what I'm saying and my solution to the problem. And so yeah, let's just get started with the first problem here. Okay, so here's your problem. There are M green apples and N red apples in a basket. You take out apples randomly, one by one, until there are only red apples left. So basically until you've removed all the green apples. And so what is the probability that at the moment we stop, the basket is empty? Have a think about it, and I'll give you the answer right away. All right, so I've erased the question just so that we have more space here. But there are M green apples and red apples, and don't forget, we pick out all the apples until there's only red apples left. So until we've picked out all the green apples. And so how do we approach this problem? The first way I thought about approaching it when I first saw the problem was try to start from a low number of red apples and green apples and try to build up from there. So, if there's only one red apple, one green apple, what happens then? Then what if we add another apple, blah, blah, blah. But as you quickly realize, it's just too much calculation to do that, and it actually doesn't really lead you anywhere. A much better way to solve this problem is to try to think about the last apple that we choose or that we pick out of the bag. So instead of stopping when there's only red apples left, we just pick out all the apples and think about what the last apple is that we pick out of the bag. If the last apple that we pick out of the basket is green, well then we already know that after we've picked out all the green apples, until there are no green apples left, well then the basket is empty. So the probability that the basket is empty after we've picked out all the green apples is actually the same as the probability that the last apple we pick out of the basket is green. Okay, so this is our new expression. We have the probability that the basket is empty is equal to the probability that the last pick is green. And remember that this probability just means that the basket is empty after we've picked out all the green apples. And this means that the probability that the last pick is green if we agree to pick out all the apples from the basket and the probability that that last pick is green. And so I know it doesn't sound like we've done much here, but this is actually very important since we can use symmetry now. And so let's think about what is the probability that the last pick is green. Well, since we have M green apples and N red apples, the total number of apples is M plus N. And since any of the M green apples and N red apples, any of those apples have an equal like probability of being picked last, this probability is actually just 1 over M plus N. Since if we add them all together, it should sum to 1. And so for each of those M green apples, the probability that each of those M green apples is picked last is 1 over M plus N. And so to find the probability that any of those M green apples are picked last, we just sum them together. So we have 1 over 1 plus M plus 1 over 1 plus N, all the way up to 1 over M plus N. And this is, we just sum this M times. And so this is actually just equal to the sum from I is equal to 1 to M of just this term right here. And this is actually just big M over M plus N. Yeah, M plus N. And so that is our solution to the probability that the last pick is green, and therefore the probability that the basket is empty. All right, so I hope you enjoyed this new format. I think it's much better for me to explain this to you on the whiteboard than just on my iPad. And so if you like this content, please consider subscribing, and I'll see you next time.